My name is Bruno Borges. I work at Microsoft, part of the developer relations team for Java developers, primarily, and for cloud developers, part of the Azure division. And thank you so much for coming to this session. There are so many great sessions happening at JFall, as usual, every year. This presentation is about enterprise integration patterns, and I'm always curious to know how many of you are applying enterprise integration patterns, regardless of what technology, product, SOAP, SOA architecture, doesn't matter, just a matter of like integration. Integration is a very interesting topic always. It's about messaging, it's about synchronous, asynchronous messaging, queuing, etc. So who actually works with integration? Okay, well, a lot. Very good. This session is about serverless and integration patterns and how these things might combine. And part of the presentation, I will use a framework called Apache Camel. And I hope it's the last time I'm going to ask you something. How many of you know about Apache Camel? Wow, okay, more than half. Great. Curiosity fact. Anybody can guess which is the most used component of Apache Camel worldwide? Anybody can take a guess? I'll give you a sticker. A nice sticker with the Java Duke parachuting. It's very nice. Anybody has any idea which component is the most used one for integration purposes? Take a guess. Say loud. File. Who's that file? Okay, you just won. File is the most used integration component of Camel. And you know why? Because it's the simplest way to do integration, right? Just send me a file, a CSV, an XML, a spreadsheet, whatever. Just send me it, and I'll process that later, right? Usually it goes over some channels. What is the second most used Camel component? FTP. There you go. Because it's easy, right? You start an FTP server and you exchange files. So great. Always work. No, nothing fails. Well, processing might fail, but that's another thing. So in the serverless world, it's more about the processing part than the actual integration. It's about implementing functions that will be processed and executed based on events. And you're going to pay for when those things happen. You're going to pay per execution and per time spent processing. And that is basically the very simple definition of a serverless platform, a serverless architecture. You abstract all your infrastructure. Here's my function. There's an input and output. Some processing will happen. It's mostly event-driven. And it's microbilling. You pay per execution. Sometimes cloud providers don't even charge you per execution until a certain point. Azure, for example, gives you 1 million requests for free every month. After 1 million, then it starts charging per request. And it's like 0.0000 whatever cents. And then you also have the cost per processing time, whether it's CPU, memory, combination of both. And each cloud provider has different ways of charging that. But that is like a definition of serverless in a cloud provider. Serverless can also run on-premise. There are many technologies out there that do that. So let's talk about these things initially, and then you're going to dive into enterprise integration patterns and get into it. So abstraction, first of all, just run my code. You charge for the processing, which means it's function as a service. That's a definition in the cloud economic way. And the serverless-based functions, they are based on types of events, whether it's HTTP, it's a cron, it's a storage event, a database event, a Kafka event, many ways that events can be triggered. And each serverless platform defines dozens and dozens of types of event bindings. So depending on what type of integration you need to do, you might have that supported in this cloud or that cloud or both, or even on open source serverless platforms. But you also want to understand why this interest in serverless. I like to go through the history of computation or data processing in general and how we set up our servers to do data process. In the old days, you would call Dell or HP or some Compaq maybe, and you'd buy servers, install them, set up cables, and then maybe at the end of the day, week or month, you're going to have an operating system which has your server and SSH enabled. Of course, that requires you to go physically at the data center, do all of that. And that was basically in the old days. Who here ever went to a data center and connected a monitor and a keyboard to a server? Well, good for you. Because you had no life, I guess. That is true. At that time. Things evolved, right? Thank God virtualization came, and when we need more servers, we just go to this web interface, or we call someone, and they just spin up a new VM, and they give us the credentials. Here's the SSH key to access the server and get root access. And all you need is just the OS. But after that, you still have to do a lot of things. httpd.conf, a beautiful file to edit manually using VI or Emacs. Usually, you would have a bunch of httpd.conf files hosted in an FTP server. You would go into your production server, FTP to another server where you have your httpd.conf files, and then copy them back to your server, and just you're gonna cross finger and hope it works. Then this revolution came, and it's all containers and Kubernetes. Just set up a container, set up a Kubernetes cluster, and give me a container, or I'll send you a container, and things just run. That's also awesome. But still, there's a lot of operational things happening here. So we developers, the reality is we don't even care. We should not care about writing Docker files. We should not care about writing YAML files. Let's talk about YAML files. So if you check my Twitter account and you search for Bruno Borges and XML, you're going to find out I actually like XML. Yeah, call me crazy, but that thing works. And there's a schema. You can actually know which nodes you can write where and with attributes. YAML, you misplace an attribute, and that means a completely different thing. And that's because of two spaces. So I have a thing with YAML. But the thing is, we developers should not be that worried or that concerned or spending that much time writing Docker files and YAML files for a Kubernetes and Docker-based infrastructure. The ops team can do that or can manage that, but we should just be writing code or business code and adding value to the products and the tools and the services that we provide. So that's why we don't care. We don't care anymore. We developers actually just want to write code, nice, funny code that will get data, process it, send data to somewhere else, hopefully do our tax, income tax in the right way. And all of that just nicely processed without errors and not caring about infrastructure. So as you can see, the history shows that things have been abstracting more and more over the time. Hopefully, maybe 2022, 2025, all of this will just be details. Even Kubernetes will just be details. You won't care about that anymore. Maybe just one day you're going to write a Java class with a couple methods, some Java dependencies, and just deploy that. And just run, and even bind it to events. So that is like the holy grail of serverless platforms. But today, there are some offerings already that you can achieve that sort of environment, whether in the cloud or even on-premise. So if you want to do your own FaaS environment where your developers, so let's say you are on the ops team and you want to provide or have this sort of function serverless approach within your on-premise data centers, you can have that. and developers can only care about writing the functions and deploying that in a very scalable way. So a couple options that you can find on the internet of Apache OpenWhisk, which is maintained primarily by IBM, OpenFast by VMware, FN Project by Oracle, Project Riff by Pivotal, Kubeless, which I don't recall who is the main maintainer, but the latest one that was announced recently is Knative, which is this sort of serverless platform on top of Kubernetes. It's like Kubeless as well. But if you are thinking about public cloud, or even private cloud in a sense, but you want to give that responsibility to someone and you're going to pay for that, that's fine. You go to a cloud provider, whether it's private cloud or public cloud, but you have access to services like AWS Lambda, very famous, Azure Functions from Microsoft, Google Cloud Functions, IBM Cloud Functions, and Pivotal Function Service, which is based on Project Riff. But Pivotal is this moment where they have Project Riff, but they also have Knative. Knative is mainly by Google and Pivotal. So there's a lot of things still happening in the serverless ecosystem, but there are choices, whether you can do on-prem, or you want to do on-prem, or in the cloud. The thing that they are they have in common, especially the public cloud services, are bindings. Here, of course, it says Azure, but you can just replace Azure and just think about things that you can do with binding events with the serverless platform. In fact, what I can do here is show you just quickly Azure Functions bindings. Triggers and bindings on Azure Functions. And you can take a look at a list of some bindings that will trigger events and execute your function. So you have blob storage, Cosmos, Event Grid, Event Hub. Event Hub has support for Kafka. HTTP, which is great for doing demos, but I'm not sure how applicable it is for production environments, production systems. Mobile apps, queue storage, SendGrid, Service Bus, Table Storage Timer, which is basically a cron tab, Twilio, and webhooks for generic, like Jenkins, you can do a webhook here. So there are many components and bindings that can be tied into your functions and trigger those events for you. So this is just a quick example of things that you can do. To understand quickly how a function is done, I'll just run Azure Functions locally, and then we'll see also running on Azure. So let me take a quick look at my monitor here and just mirror, or else I'm going to have a hard time with my neck. And here we are. OK. So Azure Functions supports Java, .NET, JavaScript, and a couple other things. One thing that for Java is pretty cool is that it supports Maven. It has support for Maven. Actually, as a Java developer, you can just do Maven. So let me maximize here. And hello func. This is just a hello world. You can generate a Maven project using a Maven archetype for Azure Functions projects. And once you have that, it will give you a POM file, a Java class with a simple. Actually, this is the initial code that they give. I just added this method here. So let me make it bigger, so big that you won't even see it. OK, let me make it smaller so you can actually see it. So this is the code. Of course, it's a Java class. It has a method, and that is the entry point. And the annotation is what tells Azure Functions what to be executed when an event happens. So I'm giving this function a name, and I'm binding this with an HTTP trigger. And the trigger, actually, yeah, I actually showed you, oh no, bindings and triggers. Where are the triggers? Overview. Who doesn't do that, right? Yeah. Oh, triggers and bindings. There you go. Oh, nice looping. Nice looping. Yeah, these are the bindings, not the triggers. Triggers. Oh, just these are quick starts. Anyways, I think these are the triggers that we have right now. Anyhow, if you want to bind an event, an HTTP event, this is how you do it. In the end, it will actually just generate a JSON file. The Maven plugin generates a JSON file, and which means you can actually write the JSON file manually, and you can even write your Java function in any Java language. It can be JVM language. It can be Kotlin, Groovy, Scala, Clojure, whatever. As long in the JSON file, you indicate the class and the method name of the generated bytecode of that method. So let me take a look at the JSON file here so you can take a look at how it works. So this is the actual function.json. So the script file here is a jar where my code is at. And the entry point is the package, the class name, and the method. And then the bindings, it's an HTTP trigger. It has a request. The direction is input, no webhook, anonymous authentication because it's a demo. Don't ever do that. And get and post. So all of this is generated thanks to these annotations. OK, cool. How do I run this thing? The archetype generates the POM file, which brings the Azure Functions Maven plugin. So what you can just do is Maven Azure Functions run. If you run this for the very first time, after creating the Maven archetype, and you don't have anything from Azure Functions, it will complain that you don't have the Azure Functions runtime installed on your computer. So it will give you an information and where to go to get that. So, OK, we have our trigger. So let's just get this thing here. And let's create a new file, save it as calls.htp. And let's call this function. So just to clarify, the function is called HTTP trigger. Here's the URL. And what it does is it asks for a query parameter called name. So let's do that. Let's do a get. And let's put a name equals jfol. And let's send this request. And there it is. That's the result. Hello, jfol. OK, so we do have another API, another function. Because on Azure Functions, you have the idea of a function application, and within a function application, you can have multiple functions, which is actually nice for a Java project because you can have this Maven project with several calls, and even dependencies, Java dependencies. It's a normal Java project. And I can just do another get, but the URL will be the uppercase. And the uppercase, let's see how the uppercase works. The uppercase is expecting a name parameter again, and it will just return the uppercase of it. So just do name equals Bruno, and we got Bruno. OK, so this is, of course, stupid running locally. So what do? We just deploy remotely. To deploy remotely, what we do is Maven Azure Functions deploy. Now, deploying will take some minutes here. I don't want to waste your time. This function is already deployed, so let's take a look at this function deployed on Azure Functions. From here, there's hello func, this one here. This one looks fine. And here's the URL, hello func. And it has two functions, hopefully. It's the same code that I deployed at that time. There you go. So uppercase. And I can integrate, I can manage, can monitor, of course. But here's the JSON file that was used, and I can actually get the function URL of this this function, this particular function. Now I'm gonna go back here to my calls.htp. I'm gonna change the URL, remove this parameter, I don't need that, and I'm gonna change to Borges and send a request. Now, it returned Borges because it's the same code, nothing special here. But the thing is that when you deploy this thing, it doesn't charge you. It's available, but it's not charging you for anything. And that is the same pattern for any cloud-based platform. It only charges you once you hit a threshold of executions or memory consumption or CPU consumption or whatever is the contract details of the billing that you selected, and then it starts charging per execution again. So with that, we covered a quick Azure Functions look at for Java. So when we think about a monolithic application and we think about how we break that down into multiple functions, in fact, maybe you think about breaking down into multiple microservices, and then you think, oh, maybe I'm going to break down to multiple functions. Maybe you're going to group functions within a function app for Azure Functions. It doesn't matter how much or how. In the end, you're going to have a lot of very small deployable units. And that is where integration patterns can start becoming useful to help you take advantage of these functions deployed everywhere and how to manage your data that goes to this function, gets processed, and then needs to go to that function to get processed, and so on and so forth. Of course, integration problems will happen. And on this chart, this is based on a very extensive research that I did by looking on Wikipedia for a couple hours. And the more integration points you have, the more problems you're going to have. It's as simple as it gets. And it's very problematic when you have a function that actually has the URL of the other function that needs to be called. You need, at the end of the day, an orchestration. And that orchestration will actually know to call this function, then that function, then that function. And Camel is actually great for that, and many other frameworks. So when you go into enterprise integration patterns, we start thinking about solutions like if this and that, which is very, yeah, I call it personal integration problems. Like here's an email with attachments, just save all those attachments to my Dropbox folder, and if this and that can do that. So for EIPs though, you actually look into that book. I hope everybody here has this book. Please don't read it end to end. It's not necessary. Just look at the very first page. There's a chart with all the patterns. Just by looking at the pictures, you get an idea of what they mean and how the messages will flow. And once you see a problem, then you're, okay, maybe I should, have to apply that thing. And Apache Camel, which is, in my opinion, the best implementation of these patterns, and has supports for DSLs written in many languages and so on. And in fact, recently they released Apache Camel for Kubernetes. So if you're curious to understand what that means, just search for Apache Camel K. That's the version of it. It's a lightweight version of Camel for Kubernetes stateless sort of deployment. But, I was going to do a recap of EIP and Camel, but you pretty much know that. And so let's just move on. Although for those, let's be honest here. If you know, don't say it. If you don't know Camel or EIP, then try to guess it. Okay? So for those who don't know EIP and Camel, what is the name of this pattern? And you can take a guess. Nope. No idea. So let's go back. This is called message filter, right? Messages are coming in, somebody's looking at and filtering the messages for you and just processing those that have low resolution. That's the code that you write for Camel. What is this pattern? What is the name of this pattern? message sorter. No, not filter, not sorter. Splitter, who said splitter? Okay, you got a sticker. Okay. Well done. So yes, this is called message splitter. And to implement that in Camel, you just do a dot split in the body, and Camel will try to process the body as best as it can, but it can actually provide Java class and implement however you want to split the payload, of course. But for example, if the body is if the payload is a JSON object that is a JSON array, it will convert to an array of JSON objects, and then it will split into units of JSON objects. But that's basically what it does. Okay, so let's take a look at a very cool demo of Apache Camel. And let's go into work, EIP, Camel Twitter, code. So this demo, oh, you don't see it, right? Yes, of course you're not seeing it, because I'm stupid. Okay, now you can see it, hopefully. All right, so on this code, let me open the route. So this code is a little bit complicated, but follow me on this one. I'm using a Twitter component that will filter tweets using a keyword that is provided on a properties file that is read initially, and then for every tweet, it will send those tweets to this route over here, to this entry point, set images. So set images is just an in-memory queue, and then for every object that gets into here, I'll process that, extract the image that comes from the tweet that has a media, process statistics, like how many tweets I'm getting per minute and so on. And then after that, I'm going to filter and see, is an object that of type tweet? Because actually the image extractor will convert the status object from Twitter4j API and convert into a tweet that only contains one image. And then I'm going to throttle that and only get up to 4 tweets per second. And then I'm going to cache this on this memory idempotent repository to try to avoid the duplicates. I'm going to marshal the object and convert into a JSON. And then I'm going to, of course, change the payload into a string. And finally, I'm going to send over a WebSocket to a listener on a web application that will be actually stored using the JavaScript and HTML files located in this folder. I also have Quartz statistics that will send every second a JSON payload of the statistics that are being processed of how many tweets I'm collecting. I actually implemented a way to send a message from the JavaScript application client side into the statistics endpoint, WebSocket endpoint, to clear the statistics. But I won't show you that because we don't need to. But finally, images. So the images is just an entry point where I can send a text that says search or sample. If I send search, I'm going to start searching for another keyword on a Twitter API. If I send sample, I'm going to change and just use the sample stream that Twitter has publicly available. So this is what this Camel project will do. To see that in running, I'll just call Maven, and hopefully it will work. And I've set the initial hashtag to be jhipster. I'm sorry, jfall. Okay, it's processing. It's got no tweets so far. So let's go to localhost. Let's open the console here. And now you have a job. You have to take a picture and tweet using the jfall hashtag. Anybody can give it a try, especially those at the back that have probably better mobile connection for some odd reason. We can just, I have a lot of time. Like, clearly I have a lot of time. All right, you guys take too long. I'm just going to fake it. So I'm going to just tweet jfall and just use some picture. Yeah, okay. I'm taking too long. I'm spending so much time. I cannot just post something stupid, right? Oh my. Okay, this one is fine. Oh, actually, okay, you guys were faster than me. Well done. Okay, here's mine. I won, doesn't matter. So it gets tweets, and then it sends over WebSocket to this HTML application. And I actually can change if I go, how do I clear? Yeah, just clear this thing. If I go app images, which is a JavaScript object in my code, my client-side code, I can just search, and I can provide another hashtag. I can say soccer, and it will flip. As you can see on the terminal, it stopped the Twitter streaming route and started over with a different keyword. So now it's just soccer, and it's getting some images like this handsome soccer player from this unknown team in Japan. So you can get an idea of the sort of code that you can write with Camel. With this cool application. And if you want to take a look at it, it's on github.com/Bruno Borges, /Camel, Twitter. Actually, I don't know the repo. So let me see, git remote. TDC on Camel. Yeah. So Bruno Borges /TDC on Camel. So if you want to run this thing, just get the source code. You have to change the APIs keys of Twitter. So you have to go to the dev.twitter.com and change on the property file resources app.properties.sample. So you have to copy to app.properties and add the keys here of your Twitter developer API, and then you can run this code just doing Maven, just do like Maven. Not Maven package, not Maven exec, not Maven compile, just Maven. Pretty easy. So easy that sometimes I forget that I can just do Maven. I try to do Maven exec and it doesn't work. So this is the just displaying Camel. But so what about combining those things? So let's take let's just go back to the slides, and you're starting to run out of time. So lots of components for Camel. In fact, for those who don't know, Camel has over 50 components now. Apache.org components. It's a huge list of components that you can write, consume. Components for Elastic, for Google stuff, for Amazon stuff, for Azure stuff, for Kafka, for Java, JDBC, databases, Jira, whatever. You imagine there will probably be a component like that. It's like your Google App Store, right? You imagine about an idea, and there's an app for that. And you imagine about integration problem, there's a component for that. So the patterns are themselves are also implemented and documented for Camel. If you look at the documentation, enterprise integration patterns on the right side, there's a link for that, and you can actually see how you implement on Camel the different patterns that you see in the book. So once you learn the patterns, it becomes easier to come up with the solutions, of course. And having the components, it's even easier. Or at the end, if you don't have a component, you can just write a component yourself. So where EIPs can help serverless-based applications? For sure, when you run a Camel application, the application itself is always running. So that becomes a consumption problem. Maybe you don't have messages coming every day. Maybe you don't have messages coming every week. So why having a Camel project running all the time, just waiting for events to happen? So that's where serverless becomes an interesting combination for integration patterns, especially when you don't have a a big amount of events happening. And then you optimize your cost. Some solutions other than Camel, of course, Spring integration, it's another idea, but you have a lot of products that can solve these problems. There is a thing called integration services, especially in the cloud. So Azure has something called Logic Apps, which you can draw the message flow. Oracle has Integration Cloud, and I think IBM probably has a solution like that. So let's just take a look at how we combine Camel and serverless. So imagine Camel, a Camel application compiled and put inside a Docker image. And then you run that Docker image in some container platform. Your container has Camel, which is the Camel context, always running, and messages coming in, coming out. Maybe a message is processed in a function in a serverless environment, which is outside Camel. And then maybe the message goes to Kafka or database. But point is, Camel works as your orchestrator of your message, of your payload. And the business logic is not implemented inside Camel, just the message flow. The actual business logic is implemented in the serverless platforms outside, which means if you have to change the business logic, maybe you don't have to redeploy the entire monolithic Camel environment. You just change the function. That is the approach here. The other thing that you can actually do is implement an integration pattern using a function. So imagine a message comes, gets into Camel, and then Camel's like, oh, I need to find the right route of this payload. Should I send to widgets or gadgets? And then I'm going to ask a serverless function where to go. And that serverless function might be changed dynamically over time, new routes being added without changing the monolithic Camel application. So that gives you a very dynamic environment where you have a very high uptime and availability. And then finally, you can actually run Camel as a function itself. You can deploy Camel inside a serverless platform. And that's where things start to become very interesting and very confusing as well. So let's take a look at a quick demo of how this might work. And just checking time. Yeah, we have just more 5-10 minutes at most. I have this Camel Azure Functions demo, which it started as a Java project to be deployed on Azure Functions, and then I started adding Camel route into it. And forgive my bloated code, but it's easy to write in one single class. So this code, first thing that this code has an endpoint that sends a message to Kafka. So that's why I have to set up the Kafka component here with some long strings that I will not screw more, because I'm also going to see my shared access key and copy that and start mining Bitcoin on my Event Hub Kafka environment. So I'll just move on. So I configure my Kafka endpoint component, and then I start adding routes. So let's take a look at the routes. First route that I have, it's a very stupid route to uppercase, but using Camel. So if a message comes to uppercase, I'm going to uppercase that, as stupid as it gets. So to look at, let's run this thing, and then I'll walk you through Maven Azure Functions run. And then just to show you, this is running on Azure Functions engine, which can then be deployed to Azure Functions in the cloud. And Azure Functions is open source, runs locally, it runs on-prem, runs on Azure Cloud, but runs on any cloud where you want to, because you can just go to GitHub, get Azure Functions runtime, and deploy whatever you want. But as a service, you got on Microsoft Azure. Okay, so it's deployed. It has some endpoints. Here's the upper endpoint running locally for now. And let's take HP calls and do a call with this one. Here's uppercase. The URL is the local URL /API/upper, which is the same that I got it from the console. Okay, and let's send a request. Okay, camel return, Netherlands, all uppercase. And here's the log, message converted, Netherlands, and the log from Azure Functions, executed HTTP request. Cool. The API, the URI was /API/upper, method was post, all very nice. Let's take a look at this code and how this was implemented. So I need to expose the endpoint, and the endpoint is a method. So it's a function name upper. It uses an HTTP trigger and gets the body, which is either a post payload body or a request parameter from get method. And then I create an exchange. So this is the nice thing about Camel API. It's very, you can program the Camel API in very advanced ways. So I create an exchange to inject this into the route. So I get the producer, which is a simple producer, and I'm going to send to this endpoint using that Camel context that was created. And I'm going to get the message that comes out and return that to the log. And then I'm going to send this back to my HTTP request response. Create response builder, body, the message that came from Camel. So this is how it does. Function comes in, event is trigger, HTTP, comes a message. I get that message. I wrap it on an exchange object for a Camel. I insert that into the Camel route. Camel processes that. And if the Camel route changes this function, it's as an entry point and input and output, doesn't have to change at all. And once I have that, I can apply whatever pattern that I think of. So speaking of patterns, I actually created an interesting pattern here that I'm basically what I do is I have this endpoint that is called message splitter. I'm going to get a JSON payload and split that into units of payloads. My payload is a JavaScript object where in the attribute codes, I have an array of strings. So let's just do something here, and let's say Heineken, Guinness, Lechoff, and Delirium. You know which one is the best one, right? So I will not say which one I like, or else I'm going to die. And I want to process this payload, but I want to break it down and split this message. So what I did was I actually put, as you can see here, there's some custom headers. One header says, what is the split pattern? This is a JSON path code. I'm going to use JSON path to break down my JSON object. I'm going to get all the elements of the array. And I'm going to send each element to this URL /API/upper, which is another endpoint. It's another function. And I'm going to use the method post. OK, so let's just run it. Message received, check the logs, because it's always synchronous as well. The payload is broken down. Everything happens asynchronously. So looking at the log, API upper processed Delirium. And the reason you see a lot of log here, because each time upper is called, the function is provisioned, and then Camel context is stored for every execution. But you can see individual executions happening, where this one here was for Lechoff, and so on and so forth. So let's look at the code, how this was implemented. First of all, there's an endpoint called message splitter, which is triggered by the function HTTP function message splitter, which creates the payload and injects into the route, and also pass on the headers as you can see here, it sets the headers in the Exchange object. Now let's go back to the Camel route definition. Message splitter, convert body to string.class, and then makes a choice. If the content type is an application/JSON, which is the case here, it's an application/JSON, it will filter. This is a message filter, and send to JSON splitter. So let's go to JSON splitter. JSON splitter will convert this into, based on the JSON path that was set in the split pattern header, which is this value here. And then for every element, I'm going to stream that to dispatch. From here, I'm going to get 4 Exchange objects, 4 payloads. On the dispatch, I'm going to get the information of where should I go next. So I'm going to look at the destination header and which HTTP method, and for now, of course, only works for HTTP, and I'm going to send that and make that a call using this nice component for Camel to trigger the call for me. And that goes to /API/upper, which is a new HTTP call back to the function upper that is defined here. Of course, all these functions are implemented in the same code, same function app deployed on Azure or running on Azure Functions, but they all could be separated. All this logic could be separated in specific serverless functions. And you can have this code dynamically written. You could even write in JavaScript if you want, and it's even faster to deploy, maybe not to debug. So the last thing is Kafka, right? I want to send this thing to Kafka, and I'll just do this thing over here. Split message and send to Kafka. And message received. And as you can see, I used the message splitter, but now I sent to queue on Kafka. And let's take a look at the logs. And queue on Kafka was processed, queue on Kafka, and info amen, and hi. And it called the Kafka serializer, it called the Kafka component, and these messages were sent to Kafka. And what you can see, the messages in Kafka, we consume all the messages that get to Kafka, we save them on Azure storage. This might take a while, so what I'm going to do is just work EIP, camel, or just java -jar. Yes, so this file I saved at 12:29 today doing this demo, so we wouldn't spend too much time. And this, camel Azure. This was the message that was sent at the time, and the code that I used was Netherlands, Amsterdam, Utrecht, and Amhai. But this was what I got at that time, and these were payloads that were sent by Apache Camel to Kafka. And Kafka is running also as a service on Azure. So, and here's the storage. The thing that I saved the file before is because the capture of Kafka object is done every 10 minutes. So it queues them, and then it saves the file every 10 minutes. So I don't want to wait 10 minutes for these files to appear. But you can see what's going on here. There you go. So every 10 minutes, it generates a file of messages. And this file here is what I did earlier today. OK, so that's how you can combine, and you can actually run. By the way, this function is running on Azure as well. It's just, I can just change here. It's this application. And I'll just call the uppercase. And just wait. It is live. You cannot see it, right? Yes, again. This company that did PowerPoint, it's crazy. It's crazy. OK, so here's the output of this code running as you can see, Microsoft IaaS, that's the front end of Azure Functions. But here's the function returned Netherlands, and I can do whatever, and it will process again. But all this is processing through Camel. It's the same code. Okay, so to wrap up, I don't have time, but if you check it out, Logic Apps is there's like a version of if this then that for enterprise, which you can define a flow of payloads. And the interesting thing is that one of the elements can actually be an Azure function, where you can just change and write the code as you wish. Even like a JavaScript code that will check the payload and send to somewhere else. It's a pretty interesting tool. And if you want to learn more, here are some links that you can check it out. And if you have questions, please come to me right after, because I ran out of time. So thank you so much.